And we are live. Good evening, everyone. Welcome to another week of our live chat. We have a lot to talk about tonight. True, there are no winter storms on the way. We do have, though, a very impressive wind threat that is setting up for Friday morning that we're going to definitely be keeping an eye on. And also, we are going to be keeping an eye on an interesting pattern evolution that's starting to show up in the model guidance that I'm sure many of you have seen on social media, the discussion or the potential for a cold start to March. But we need to preface this a little bit because there are some factors here that I think need to be considered. So what I want to show tonight is first we're going to talk about the wind threat coming up for Friday morning. And then we're going to talk about the pattern change and the pattern evolution as we go from February into March. And then I'm going to take your questions, which I normally do every night. In the meantime, geez, a lot of people already on the chat, so that's awesome. So let's dive right into this and take a look at what we have here. And right here. Okay, so first we're going to take a look at our upper level winds going up right now. And you can see we have a nice trough over the west, a pretty robust jet streak here in the subtropical jet stream. And we have another one here over the polar jet stream. This is typical of a La Nina pattern here, where you have your ridge over the southeast, especially around the Bahamas. And without any type of immediate influence from the polar vortex, because it's converging and contracting, that leads to our polar jet stream lifting northward, and our ridge is able to build. Now, this matches up pretty nicely with the current MJO pattern and also the current weak La Nina pattern. So here is our southeast ridge, which is what we typically see. Here is the concern for Friday morning. And this is at about 3 a.m. These winds range anywhere from 90 to 100 knots on the NAM guidance. Now, this might be a little overdone, but I've been seeing on a lot of the synoptic models, whether the GFS or the European guidance, anywhere between 65 and 85 knots, which seems a little bit more realistic. The concern here is that with some of the heavier downpours that are going to be moving through early Friday morning from about 1 a.m. to 6 a.m., some of these winds are going to be able to get mixed down, and that's going to lead to some pretty strong wind gusts. There's already wind advisories out for eastern and central Long Island and eastern Connecticut, understandably. I think that should probably be extended for much of the New York City metro and for much of the Jersey Shore. You could even make a case for portions of the Delaware River Valley here. So what this is going to lead to is easily sustained winds of 15 to 30 miles per hour and the potential for gusts over 40 miles per hour. In some of these heavier downpours, which let me pull up the NAM radar depiction here. Here it is. Here we are. Okay, so if we work this through here. Okay, it's these showers right here. Like this one right here, this one around Trenton. Not that it's specifically going to be a Trenton, but it's the intensity of these cells that are going to be able to tap into some of those strong winds at 850 millibars, and because of the heavy rainfall, mix everything down. So as a result, you can end up with some wind damage. Definitely possible. I think if you have anything that's outdoor and loose, I'd strongly suggest bringing it indoors tomorrow afternoon before this rain starts to come in late tomorrow evening. And likely these power outages. So I would just be prepared for that for Friday morning. Not exactly going to be the best conditions for the early morning rush hour. The good news, though, is that this clears out pretty quickly. And by about 9 a.m., most of the heavy rain is out over the ocean. and everything starts to clear out. Don't be surprised up towards the Poconos. You get a little bit of a snow shower or two. No real accumulation out of it, though. But that's going to tell you just how fast these temperatures fall off. Let's take a look at the surface temperatures for Friday here. And you can see earlier in the morning, we are pretty warm. This is pretty much our high temperatures on Friday. And then there on out, once that cold front clears through, temperatures just fall the rest of the day. So your high temperatures in many locations are basically going to be around 6, 7 a.m. on Friday. And then thereafter, temperatures just fall throughout the day. Or if you're in the Poconos, basically hold steady from the morning lows. So it's going to be a bit of a chilly afternoon. Very warm morning on Friday, but a chilly afternoon with temperatures falling off into the 20s and 30s. So you definitely want to be prepared for that as well. Now, I know everyone's here for the discussion on the pattern change. There's a lot of interesting data showing up, and let's start off first with what everyone was seeing first to kick off this conversation, and that would be the European weeklies. Okay, and what everyone was noticing was this indication, this time period right here in early March, where you get this trough built in, and as a result, it leads to temperatures, let's see here, averaging below normal, enough to make things interesting. And you're also seeing that in the ensemble guidance right here in the late February to early March. You're seeing this trough. And so naturally, everyone's going to the temperatures. Let's see, probably this one right here. And of course, everyone points out, look, below normal temperatures, winter is back. So, a couple of things. First of all, how do we get to this point? Well, we're getting to that point by these factors. One, we're seeing stronger EP vectors, Elson palm vectors, which allows for, and again, we can see it in the observations here, where it allows for the transport of warmer air, and you can see it right here in the observations. This is what's causing this stretching. So as a result, the models, and we'll use the GFS this time, GFS ensembles, and we'll use 12Z. And you can see it's doing this stretching factor right here. And in the operational, it's even more aggressive, almost trying to split it. Now let's pull up the GFS. It tries to go as far as trying to split the polar vortex. So why am I, let's say, questioning the veracity of this potential? Well, the problem here that I'm seeing, and let me see here, I think I want to use Julian, is the temperature. Here we are. Okay. So when you're analyzing this whole scenario here, what you want to do is understand what is the base environment and that all this is going to occur. Now, I do not dispute the idea of a stretching polar vortex, basically because of what we're seeing with the observations I just showed you right here. Okay, so it makes sense. Okay, so you have this warm air coming in, should cause a little bit of disruption in the circulation. But is it strong enough to cause a split? The problem with that is that our temperatures at 50 millibars down to 100 millibars is historically below normal. This chart here is basically your climate average of what you would expect in the stratosphere. Okay, now normally normal is right around here, right around where we have this yellow line. And then your variance in normal is in this dark gray section. Then you get your above and below normal ranges here. And then when we talk about major stratospheric warming events, well, that's usually up here, right? Same thing with cooling events, right? Right down here. What we're dealing with here is something that will change this boundary. It'd be the equivalent of if we had a major historic stratospheric warming event, and that leads to a significant disruption in the polar vortex and high latitude blocking, and everyone gets excited and everyone gets very, very hyped about the potential for winter storms. Well, this is the exact opposite of that. This is very cold. Now, I want to explain to you why this is important. Okay, so I'm going to use my hands here. Let me zoom in here. Okay, so when it comes to the stratosphere, remember, in the atmosphere, much like in everything with science, there's always an equal and opposite reaction. Okay, so when we're talking about a warming stratosphere, okay, and I'm going to go like this, okay, when it's warming, you get an expansion in the stratosphere, right? And that expansion pushes down on the troposphere, which is where we live, and causes it to collapse. Okay, shrink. That shrinking causes below normal heights and the better potential for upper level lows, deeper upper level lows, and the better potential for high latitude blocking. Well, when we see the opposite, in which you're seeing a contraction in the stratosphere, then you have an expansion in the troposphere, okay, to balance everything out. And that expansion leads to a higher base level in the 500 millibar heights. It leads to high pressure systems becoming stronger in the mid latitudes, i.e. the southeast ridge, and also leads to a polar jet stream that tends to contract northward. Okay, so yes, you have a stretching polar vortex, but you also have a very, very cold environment in place in the stratosphere, which has other impacts, which we just described. So how do you balance those two out while at the same time you also have tropical forcing with the MJO? Now, let me just show you the various models of the MJO and show you the theme here. I'll walk you through it, and then we'll talk about the theme. So there's the GFS versions. Here's the CFS versions. European, Canadian. There's another European. Here's a European long range. Okay, so all of these models have a general theme. Okay, now you never want to take this stuff verbatim, but you go look at the theme. And the theme basically is taking you from phase 3 through phase 4, 5, 6, through the middle of March. Phases 4 and 5 and 6 tend to lead to a stronger southeast ridge. It also leads to a stronger thermal gradient setting up right around the Great Lakes, through, let's say, about New England. So it leads to a scenario where, and let me pull up a satellite picture. Okay, so what typically happens in this scenario is that you get a robust southeast ridge here. But because you have a stretched polar vortex, you get a constant trough around, let's say, around Hudson Bay and Greenland and Ontario. You get an Arctic air mass that sets up around the St. Lawrence River Valley, but you also get a modified Pacific or even tropical air mass up through the southern mid-Atlantic. So we basically get stuck for the end of February into March into a battle zone here. What I think we're going to be setting up here is a scenario where the coastal plain gets a lot of rain out of this. Maybe you might start off with a little bit of snow, sleet mix, but you eventually go over to rain. And the reason why is because in this pattern, and you can even see this And let me pull up the 500 millibar pattern here. Here we are. Even in this pattern here, in this configuration here, this is a positive negative NAO pattern, or positive NAO pattern, okay? So this is a progressive pattern, okay? This allows your storm tracks to cut up towards the St. Lawrence River Valley. So what this all translates to is that for you guys in the Lehigh River Valley, the Poconos, the Catskills, who have been saying, hey, where's my snow? This is a pattern where you can get your snow. This is not a winter storm pattern for the coastal plain or for the major cities, because you don't have the blocking necessary to keep cold air locked in. So you end up with a pattern where you get like 2 or 3 days of cold conditions and then you rapidly moderate. So actually, it may be more like 1 to 3 days. Whereas those of you in the Poconos and Catskills, you get that Arctic source that's close by in the St. Lawrence River Valley, is able to bleed down towards northern Pennsylvania, maybe even northwestern New Jersey and the Hudson River Valley. Heck, you can even include portions of northern Connecticut. And it takes longer to give way, but it's still a snow to freezing rain to rain type scenario here. This is not a pattern that would support pure snow. This is a pattern where you get a lot of transient cold air masses, but the warm air constantly wins out. And this is a pattern where I think New England is in for a very snowy early March, beginning of March. But for us, more of a cold rain on the coastal plain, wintry mix over the interior type scenario. And the reason why is because the position of this upper level low means that you really cannot lock in cold air in this scenario. Because in this position, yeah, you can get cold air to push in initially, but because there's no block here, any low pressure system that develops in the Tennessee River Valley is able to cut over the interior because there's nothing to stop that from happening. Also, another thing to keep an eye on is this ridge axis here. Anytime you have a ridge axis out here and getting ready to retrograde back towards the central Gulf of Alaska, that tends to mean that this trough pattern is not going to be able to last very long. Let's see here. Make sure everything. I just got notice. Hey, Hun, is the video working okay?
It paused for a bit. It was like it's back now.
Okay. All right. So I'll answer your questions. If anything got missed, I'll go over it again. But that's generally what I'm looking at here in this pattern that's coming up. I do not see this as the same type of pattern that we saw in January, because we're dealing with a different environment. Obviously, first of all, it's going to be late February to March, so your sun angle's higher. You have a much colder stratospheric environment, which means that your EP flux only has so much influence and ability to change your 500 millibar pattern. And also, the stretching of the polar vortex, I think that it is limited in time. And I think that even on the GFS here, on the ensemble guidance here, notice the rebound towards the end of this period. See, there's your stretching. Now look how fast it consolidates. The fact of the matter here is that this is still a very strong polar vortex, and this is going to cause a retraction in the polar jet stream that's going to keep our polar air masses constantly lifting northward and not able to stick around. So that's what I'm thinking right now. This is not... I don't want to say that there's no chance that we can't see snow out of this pattern, because that's always a mistake to make, at least until you get past March 15th, okay? I know a lot of people are looking forward to an early spring. I think we will see plenty of occasions of spring-like temperatures. Hell, we'll see it tomorrow. But if you're looking for this pattern to be a big snow producer for the I-95 corridor or the coastal plain, you're going to be sorely disappointed. If you're looking for this to be a major snow producer for the interior, be prepared for ice in this pattern. That's where I think that we're heading here. So now I am going to go through some of the questions here we have on the chat. And of course, I'll check out YouTube as well once I get done. So Matthew Myers asks, oh, of course, and good evening, everyone. Oh, what in the heck is that? Okay.
One of the neighbor's kids has a whistle.
Oh, wonderful. All right. Well, if you hear a whistle in the background, that's because of our neighbors. Yay. Matthew Myers asks, is the polar vortex present during the summer months? And if so, would a sudden stratospheric warming event cause cooler weather in the summer too? No. Well, all right. That's not exactly right. The polar vortex becomes extremely weak in the summer, and that is because with direct sunlight on the Earth, right, on the North Pole, right, it causes a general warming and uniformity in the stratosphere. That causes the polar vortex to weaken significantly, almost to the point of complete collapse. So there is no typical major warming or cooling because of direct sunlight on the North Pole and on the higher latitudes leads to just a basic uniformity of warmth. So you don't get the type of thermal gradients that you would in the fall and winter, which causes a polar vortex to develop, intensify, stretch, and split apart depending on what environment. So in the summer, the stratospheric environment is not that important in the higher latitudes, but I do keep an eye on the stratosphere in the mid latitudes, because what happens is that if you're looking for a heat wave signature, typically what happens is that you see a lot cooling in the mid latitudes, like around the central United States. And the cooler the stratosphere is over the United States, the stronger the heat ridge will become at the surface and at 500 millibars. So it's kind of an inverse. You want to look for rapid cooling happening around the United States at 50 millibars, which then translates to a very strong heat ridge, which then translates to a feedback scenario and a sustained heat wave. So those are the type of things I typically look for. Card says some major severe weather tomorrow according to SPC. Any chance some of that works its way further north and east as a front gets near to us and passes through? I think the key is going to be the jet streak here. And then I'll pull up 850 millibars now just from the European. And this is 18Z. Okay, so this jet streak here, especially between 1 a.m. and 4 a.m., really has my attention because I think it's going to cause enough vertical wind shear, especially via speed shear, to create some turning in the atmosphere for some of these low top thunderstorms. I don't expect a lot of severe weather, and certainly nothing like what you'll see down towards the Tennessee River Valley and towards the Mississippi River Valley. But I would not be surprised if a thunderstorm or two becomes severe in this scenario. My primary concern is going to be those strong wind gusts and the potential for some wind damage. Let's see here. Any potential issues on Friday morning commute? The early morning commute, poor visibility, heavy downpours, possibility for some urban flooding, definitely some small stream and river flooding will be possible, especially if you have any ice jams or anything of that nature. And of course, wind damage, down trees, stuff like that. You're definitely going to have to be aware for that. I would say by the time we get to the mid-morning commute, a lot of those issues will no longer be a problem, but the early morning commute will have some impacts. Let's see. Card says temperatures at 70 millibars are colder than those at 10 millibars. That's true. Stream of warm air from tropical areas at 10 millibars seems to have cut off already. Looking at Earth News School, and most of the 70 millibar stretching is to the opposite side of the globe from North America. It looks like someone may get some cold there, but not so much the U.S., much less the Mid-Atlantic, if the troposphere reacts accordingly. Well, okay, so Let me pull up what he's talking about here. And we'll go here. Make sure we have HD. Okay, so this is 70 millibars, and here is our polar vortex. Now you got this piece here, and then this piece getting warped here, right? And then remember, we have all our warming up here. So that warming that's developing is basically influencing the structure of the polar vortex. Now, the orientation of the polar vortex would support cold air dropping south, but notice this part here kind of takes everything from west to east. So earlier in the season, in January, you had this whole jet streak dropping south, and you had the transporter Arctic air dropping into the Great Lakes and moving through the mid-Atlantic. Because of the evolution of our polar vortex becoming so strong here, you can see right here, very strong here, this leads to everything contracting. Okay, so think of it as like a ballerina or an ice skater pulling their arms in so they can spin faster. Well, when you're pulling your arms in, you're also pulling northward and closer to you the polar jet stream, which is pulling a lot of that cold air, the heart of the cold air, further northward. So while you can still get pieces of cold air working their way into the northern mid-Atlantic, it's just not sustained in this type of environment. Do you anticipate there being many cutoff lows this spring, or will it be pretty much a zonal flow that mainly trough ridge and response to tropical forcing? I don't see this as a pattern that would feature a lot of cutoff upper level lows at this point, mostly because of the nature of the stratosphere being so cold right now. Typically, what I expect in this type of pattern is a progressive pattern to continue. I don't see any support for any type of high latitude blocking. I don't see any support for any type of ability for a trough to kind of cut itself off at this point. This is going to be a spring where we're going to see a lot of fast moving cold fronts. And I would not be surprised if we see a spring that is active with severe weather that we're going to hear a lot about in the plains and the Mississippi River Valley, Tennessee River Valley, and eventually getting into our neck of the woods. I would not be surprised to see the same activity that we saw last summer and last spring, this spring, and this summer. Let's see here. Looks like a pattern we were get some pretty heavy rain a couple times a year, a couple times a week, which seems to be setting up flooding. That's definitely a concern that I have for this spring. George asks, you had mentioned a week or two ago that you saw the potential for more severe weather in our area in the coming weeks. Is that still on the table as we move into March? Yes. I do think that we're going to see a higher potential for severe weather, especially once we get past the middle of March. I think that we start to see more of a unstable air mass coming in from the Gulf of Mexico. I think that we're going to see still more robust shortwaves in the polar jet stream impacting our region, what's going to cause for a lot of vertical wind shear and the potential for thunderstorms that are going to be more dynamic. One thing I'm keeping a very careful eye on is the precipitable water values. Now, this is also a climate factor as well. Over the past several years, we've seen an enhanced precipitable water value. When I say enhanced, I'm talking about precipitable water values pushing above 2.5 inches, which is very, very unusual compared to where years past. And based on research I've done on precipitable water values in the summer, usually 2.5 was just associated with tropical cyclones. Now we're seeing this with regular cold fronts. The reason why this is important to consider is that the higher your precipitable water values are, the better chance you have for frequent vivid lightning, the potential for more hailstones developing because you have more precipitable nuclei, You also have an increased potential for very intense heavy downpours, and those heavy downpours translates to a higher potential of mixing down mid-level winds, which increases your downburst wind gust potential, and the downburst wind gust potential would enhance your tornadic potential because you have more turning in the atmosphere. So one factor leads into the other, which leads to a lot of problems. So that's something I'm going to be keeping a very, very careful eye on for this summer. Dave asks, last Friday inside you had our motorcycles out finally. Bring on spring. We got spring fever. Yeah, let me tell you what to expect in terms of that through at least the middle of March. Complete anarchy when it comes to temperatures and trying to plan what you're going to wear for the week. I can tell you that much right now. This week is a perfect example. We started out with frigid temperatures where I'm bundled up with hats and everything, and tomorrow it's going to be close to 60. Some people might not even need a coat. And then that's going to continue into Friday morning until you get to Friday afternoon where you're falling through the 30s and falling below freezing once again. This is the type of weather that gets you sick. So, yeah, it's not going to be pretty the next couple of weeks. Very volatile. A good way to describe it is basically being on a roller coaster. Let's check out and see what's going on let's see, on YouTube here. Oh boy. Winter is over in the East. Never say it's over. Anybody who says winter is over, this is like buying a snowblower in December, right? Because every time someone says that, it just leads to a jinx. Let's see here. Okay, all right. I guess I'm going to have to touch on this. Why does Tri-State Weather have a beef with you and feel the need to call you out on Twitter? I don't know. Okay. Sometimes when you do something that's independent and you do something that stands out, you get some people who, I don't know, need to attack you for whatever reason. All I could say is this. If you're a young meteorologist, and this is just in general, if you're a young meteorologist, you're someone who's starting out, you're in college right now, whatever, it doesn't matter what someone else is forecasting. It doesn't matter if someone busts. And look, I'll be dead straight. The forecast for last Sunday was a bust. Okay? I thought we were going to have a less significant system. The 700 millibar omega values really overwhelmed. It was much stronger than what I thought it was going to be. And it was a bad forecast. I will admit it. I admitted it that day. I wrote a long discussion explaining what exactly is happening. It's going to happen. You as a young meteorologist, you're going to have a bad forecast. You're going to have a down time. You may be working all day on it, and you may be, looking at everything and thinking, okay, I'm confident in this forecast. It ends up being wrong. And that's okay as long as you admit it and you learn from it. And you tell your clients or the general public, hey, look, this forecast isn't working out. Looks like there's going to be more significant snowfall, whatever. Okay? That's all fine. That's all part of the game, so to speak, right? Because you're constantly learning how to deal with chaos. And you're going to miss something. It's going to happen, okay? Trust me, I've been at this for over 20 years. God, I can't believe I'm saying that. But over 20 years. And I've had plenty of storms I have messed up, and you're going to mess up too. It's okay. What's not okay is to go on to other people's social media or forums or whatever and try to, I don't know, promote yourself by highlighting their mistakes. One, it's going to catch you sooner or later because you're going to have something wrong happen and everyone's going to point out on you and then you're going to be angry and all sort of stuff. It's just bad karma. But it's just really unprofessional, okay? Whether you actually have a degree or not, okay? If you want to be taken seriously in this field, you don't need to point out other people's mistakes because believe me, you're going to be making plenty on your own. So my big beef last week, when this all went down on Sunday, was not so much that they were going to attack me. I frankly don't care. But I have an intern who is learning, who's going to be absolutely amazing in graduate school, who I think is going to be an outstanding meteorologist. And we both had a bad forecast. And it's going to happen. And I just think that, first of all, this intern doesn't have the social media presence to stand up to that type of thing yet. And they're still learning. And I'm still learning. I'm going to be learning for the rest of my life. And it's just wrong. It's just unprofessional. If you want to be good, if you want to gain a following, if you want to gain respect in this industry, just focus on you. And that's it. As far as their beef, I have too many things on the stove, so to speak, to worry about them, right? But I just won't stand for them attacking my intern. Let's see here. Let's see here. March looks to come in roaring like a lion. Yeah, I definitely think so. I definitely think it's going to be stormy. Not necessarily a snowy pattern, but definitely a stormy one. 19th anniversary. Today is the 19th anniversary of the President's Day Blizzard, 2003. Yep. Let's see. Some good questions. Okay. Generally, any snow potential. I don't really see anything, at least over the next 10 days, even for the northern interior. I think this is a pattern right now, at least for the next 10 days. It's going to be relatively warm. Let me pull up. And the simple way to tell is by looking at the 500 millibar PVA here. And when I'm looking for a winter storm signal, what I want to see is a trough starting to dig towards the Delmarva Peninsula, and so that would draw cold air southward. I really don't see anything of that nature setting up. What I see here is a lot of systems where you get a lot of cold air trapped up here, and you get a lot of isotropic lifting. And we'll pull up 850 millibar temperatures. Yeah. See, this is a pattern that's going to be generally warm. Now you see this signature right here. This is a great time to really discuss this real fast. This type of signature right here is exactly what I was talking about for at least through, let's say, the middle of March, where you get a lot of your warmer air down here, a nice little southeast ridge really doing its job. And you have all your Arctic air from your stretched polar vortex up here towards Quebec and Ontario here and down towards the St. Lawrence River Valley. In this type of scenario, whenever you have a storm tracking up towards this region, this area right here is where I'm concerned about in this pattern, where you're going to see a good potential for snow, sleet, freezing rain. This area down here is where I see, you could start off as snow, but then you just change over to rain very quickly. And the reason why is because of your wind directions at the surface. I'll just make this very easy. In this type of scenario, an east wind will lead to temperatures jumping in the 40s very quickly and snow quickly changing over to rain. This would not be a pattern just yet for backdoor cold fronts. That is going to need that upper level low to set up somewhere around, let's say, right around here. And then you get your backdoor cold front set up. But in this scenario, you have more of a stronger low pressure system here cutting up towards the St. Lawrence River Valley. So your potential for a stalled frontal boundary is more likely towards southeastern New England, through the central Hudson River Valley, and then up towards the Finger Lakes here. Okay, back towards the premium chat room. Let's see here. What particles from the big volcanic eruption are influencing the formation of cloud nuclei? Around North America, none yet. We still got some time before we get to that point. I would say that there's a greater influence around the tropical Pacific, but I haven't noticed anything that really stands out as significant just yet. I know that there's still research and a lot of data is still being collected on that. But for right now, there isn't anything that's standing out in the observations. The idea is that that should change as we head into the spring. How that influences the cloud formation, I think that you're going to see a lot more convection and a stronger MJO influence as a result this spring between the Indian Ocean and Hawaii. And that's going to be a very interesting driving factor for us in terms of severe weather potential and a trough axis focused more towards, let's say, Oklahoma and Texas and lifting northeastward. But we have to watch it. It's a big wild card. Dave asks, we have some of our biggest snows around here in Harrisburg, PA in March. That's true. 50 degrees for a week, then low 30s and a foot of snow for 24 hours, then back into the 60s and flooding. Roll the dice, winter is over, catches a lot of people off guard. Absolutely correct, Dave. This is the type of pattern that would feature that type of scenario specifically. I would not be surprised if we get a storm, okay, between now and March 15th, where it's 55 degrees the afternoon before. It crashes right to around freezing, let's say 30 to 32 degrees. Heavy snow takes hold over the Poconos, portions of the Lehigh River Valley, the Catskills, and then later on that afternoon, as the low pressure system lifts northward, you mix over to rain, and it's in the 40s and half of it's melting, and then you get flash flooding. I definitely see that type of scenario playing out, not only for the next couple of weeks, but also into at least the middle of March. Then those same storms, as we get towards the second half of March, end up being mostly rain events and becoming major flooding issues, especially over the higher elevations. I see we have. See if I can get rid of this guy.
Yeah, please.
Remove. And let's see here. Okay, I took care of it. I am report. I think that took care of him. There it is. Okay. Sorry about that, guys. Okay, so let's see. We are already at 8:43, not bad. So let's see if we got any new data in from 18Z European guidance on our storm threats. Actually, you know what? I should use. And then we'll take a look, see if the NAMs come in yet. So this is a scenario setting up, for Friday morning. You see this out here, these features right out here. This is what's going to mix down those stronger winds, and it's a big concern with those heavier downpours. Now, a lot of this looks like to be taking place between 1 a.m. and 6 a.m. Latest data, by the time we get to 8 a.m., most of the heavy rain is done. Oh, we got a new question here from Jonathan Cohen. A wonky question about snowfall statistics. The other day, someone asked me, "What's the average snowfall in their town in the northern Philly suburbs?" And as far as I could tell, no such authoritative statistic exists. All we seem to have are the airport totals, which are laughable unrepresentative. Are you aware of any public or private database with this information? It's kind of hard to get town by town snowfall statistics. You can kind of go with an average. The National Weather Service has like a basic average. Let me pull up. Let me see if I can pull up some of this data here real fast. But what you want to typically do is you go to the National Weather Service, you go to winter weather, and typically, snow and ice observations, you can go to the National Snow Analysis. Okay? And on this website, okay, National Snowfall Analysis, nohrsc.noaa.gov, or you could just type in Google National Snowfall Analysis, and you could typically get a seasonal average, and you can go back several years, going all the way back to 2008, 2009. And you get it from a variety of different data sets. Now, it won't be perfect, okay, because collection of data really hasn't improved as much until the past really 20 years. So we've gotten a lot better, and part of that is because of social media and the expansion of a lot of our observations and official observation keepers, okay, with the National Weather Service. But in order to get a specific concrete total, especially for a smaller town, that's going to be really, really difficult to pull off. And that's why a lot of people usually go with an average close to the cities or a major town like Harrisburg and whatnot. And typically where you'd get that data is if you go back here to your climate and past weather, and you get your basic climate zones. That's really the best you can really pull off. It has definitely expanded than what we've seen over the past 10 years. I mean, heck, when I was in college 20 years ago, we didn't have like Freehold Marlboro in New Jersey. We didn't have like Long Branch specifically with that data. This is all a significant upgrade over what we were seeing, a long time ago. So the data has improved. And when you have improved data, you get better answers. But unfortunately, because we just haven't had the tools and equipment, our ability to be that specific is really hindered. And that also is why when it comes to model guidance and trying to forecast, you can have the best resolution in the world, but if you don't have sound data to put into those models, you still end up with a suspect forecast. So this is part of the problem, and this is why we need more investment into mesonets to get more data and build a better database. Card exercise. So the theme for the rest of February into March is that we get to ride the roller coaster. Absolutely. That's perfectly phrased. That's absolutely correct. I would think university towns like New Brunswick, State College, etc. may also have decent records. They do. Not all of them are always public, and sometimes you have to pay for it. I'm pretty sure Penn State does. I think Rutgers definitely does. In fact, let's see here. Observations. Let's see. See if I have it saved here. Here we are, Rutgers University. Yeah, if you go to their home, you could definitely pick up a lot of the data here from Rutgers University with available data. And you can get all the documentation, not only from the North Pole and snow in general, but also you can make data requests and reach out to them as well. So definitely Rutgers is another good source. Let's check out YouTube. Oh boy. Okay. Okay. Well, we'll take care of him. Let's see what else we have here. Let's see. Some good questions. Not change over the rain. It's really going to be. Let's see here. Doesn't sound okay. Beckett asks. Doesn't sound like the sound of that. What I really want to know is, couldn't we see a full-on snowstorm for the Northeast New York City region if the storm gets to use when temperatures crash as we have an okay. All right, I get this. Okay. So Beckett and pretty much everyone else. What you're describing is basically a perfect scenario. So if you get a low pressure system to develop at just the right time to interact with the short waves, at the same time the southeast ridge is displaced to the east, and you get a perfect phase set up, let's say in the Tennessee River Valley, while the cold air comes in at just the right time, yes, you can end up with a snowfall. Understand everything I just said there. If literally everything in the atmosphere works out and everything comes together just right, and you get all your mesoscale banding and all your jet streak interactions all to work out in an unfavorable pattern to begin with no high latitude blocking, sure, you could get snow. The ability for that to happen, let's just say I wouldn't bet on it, right? I wouldn't put my savings on that. That's asking a lot as pattern. You know, it becomes a bigger issue. I think I just fixed your issue, Hun, but being a moderator. Okay. If I recall correctly, Rutgers also does pond level data, don't they? Yes, they do. I actually checked that. They actually do. They do an excellent job at that. So let me just pull up the radar real fast. I just wanted to. Whoop, that zoomed in a little bit too much. Hi, West Virginia. Okay. All right. So the reason why I'm pulling this up now is I want to see the precipitation shield that's going to be heading our way in the next 36 hours. Now you see these cells out here, right? They're not going to be particularly severe, but this is what I'm concerned about that's going to mix down those winds. And let me pull up 850 millibars. Yeah, it's already starting to form out here. Let's take a look at this. Okay, so this is the jet streak that we're worried about here. Now, it's coming right out of the Gulf of Mexico. It's already starting to intensify. The concern here is that not only is this going to bring in some strong winds, but also it's going to enhance your precipitable water values, pushing to around 1.5 inches. Why is that important in the atmosphere? Well, it opens up the potential for some very heavy downpours setting up. And that's going to lead to the potential for some of these thunderstorms to produce some localized flooding as well on Friday morning. Don't be surprised if you wake up to basically the sound of very heavy rainfall on Friday morning around 4 a.m. with very strong winds. This is all setting up perfectly based on what I'm seeing with the observations. It's aligning to what the model guidance is saying. Why does it feel like we have not gotten many Alberta clippers this year? We actually have. They just haven't been very strong. And so most of the Alberta clippers have weakened into troughs this year once they got through our area, but there have been plenty of them, just not very strong or ones that would lead to powerful winter storms. Let's see here. All right, let's see here. Do you think the winds will be bad? Winds are going to be bad throughout the entire region. A baseline 40 mile per hour gusts. I could definitely see the potential for 70 mile per hour wind gusts around 4 a.m., especially around the Jersey Shore, Long Island, southern Connecticut, and southern New England in this scenario. Not widespread, but someone's going to end up with those type of wind gusts. And that's why I'm concerned about down trees and the potential for some power outages on Friday morning. Seems to be some decent precipitation ahead, well ahead of the front. Doesn't bode well from a flooding standpoint. Agreed. Along with the melting snowpack, that's why we have flood advisories already out in northeastern Pennsylvania and portions of right basically around Binghamton. I think that's a really good advisory to put out by the National Weather Service because with all the snow melt that we're having, it's going to lead to some ice jams in some of those rivers, and combine that with the heavy rainfall, it's going to lead to a real mess. So again, Friday morning, early Friday morning, one preface, early Friday morning, 1 a.m. to 6 a.m., it's not going to be pretty if you have to drive or you have to be out and about that early in the morning. But the good news is that by 8, 9 a.m., everything's going to be pretty much clearing out. See, and that's a good question on YouTube here. It seems like every storm needs to be perfect timing. Yes, the reason why is because of the lack of high latitude blocking. This is why a negative NAO is so important in the winter for major winter storms to pan out. Because with a negative NAO, it slows the whole pattern down to increase the potential for interaction and phasing. If you don't have that, then everything has to be timed perfectly. When you do have that, you could still have a shortwave off by a little bit, but there's still enough time for it to catch up and to interact and phase and produce your major winter storm. Without it, you really don't have that chance. All right, well, it is 8:57 p.m., and that means it is time to shut it down and to call it a night, so to speak. Again, wonderful chat. I'll take one more question if anyone has it on the premium chat. If not, then we will shut it down. And looks like we are set. Okay, so just to recap, heavy rain event and strong wind event for Friday morning, early Friday morning. Just be prepared for some very heavy rainfall and the potential for some wind damage and for power outages. Do you expect the soggy ground at the surface with perhaps some deeper frozen soil from winter combined with the wind will enhance trees coming down? Certainly a potential. I think that like your older trees are going to have that bigger potential. I don't think that that's going to be a widespread issue, though, at least not yet. And in terms of the pattern moving forward overall, very volatile. Perfect description is roller coaster pattern where you're going to be in the 60s and the 30s within a 24-hour period back and forth. And it's going to be a very active weather pattern. But if you're looking for snow and ice, or, well, hopefully not ice, but definitely snow, it is the Poconos, the Catskills, and your northern interior that's going to have the best potential in this pattern. The closer you are to the coast, the more likely we're going to be dealing with a lot of rain events. So that's it for tonight. Thank you again for being part of this live chat. I really appreciate it. I will see you next week at the same time, same place. In the meantime, stay safe out there.